Come back to Techno Innovation Hub. So it's going to be another session from Oracle portal. So let's continue our architectural journey on the non-multitenancy architectural explanation. And let me share the screen. So in the last session, we were doing the practical hands-on with our large pool with parse ingest memory. This is what we were discussing. Parse ingest, and let me switch to the practical environment. So let's continue our hands-on, and we have been following this document. So the issue came was this one, create table. When you try to create the table, it created right away, but now that is because I have set that particular Exadata parameter. So I have put the things back to the original situation, where when you start the practical, the issues that you will be facing. So in my case also, now I am back to the same situation. So at the moment, I haven't set any parameters. So not the mem optimized parameter, not the Exadata parameter. So everything is on the default situation. So let's see to enable this feature and what are the issues that are going to come across. So this is we learn the mem optimized parameter. This is the parameter. The deferred insert pool or the parse ingest, that's the feature. And this is the parameter that we have to enable in intrafile in order to give enough space for the large pool. But let's do it and do hands-on and see. And last session we mentioned that this is the feature where when a continuous data stream is coming, non-interrupt data entry is coming from devices like IoT, like traffic cameras. So that's what the example gave. And Oracle has to continuously capture this information, because the objective is to do the analysis later, because most of this information, why it is being captured for analytics, data analytics, to visualize as to what happened. So analysis will happen later. We need to capture the data as much as possible and store it. So that is where this parse ingest feature is coming in. By bypassing the normal insert operations, which is happening via database buffer cache, this is going to the large pool. Now let me show you the current situation at the moment. If you just type show parameter, yeah, that has to, I think the backslash was there, so it's okay. Show parameter, let's copy that one again. At the moment, I don't have mem optimized, size is disabled and 0. And if you take a look at the hidden parameter, now it is been disabled. I just disabled that one. Our Exadata parameter, let me clear this way. So full screen. So the Exadata parameter is disabled at the moment. Exadata feature on. Something is wrong. Okay, I didn't finish this pooling. Let me do it again. So this was the parameter. EXA, yeah, Exadata feature on. So at the moment it is on true. So that's not the default. So we need to disable this parameter Exadata feature on. So let's disable this parameter. So because if this parameter is on, this feature will work because I am in 19.3. It is not 19.12 because in 19.12, as per the previous document I shared, the feature is working without any extra workarounds like this. But if you are using 19.3, any lower versions but 19.12, we have to do these workarounds. And so let's, at the moment, if I just create the table, so let's drop the table, drop table MOPT. Purge. Okay, so this is for learning only. In production environment, you better not try these things with hidden parameters. This is in a learning environment. Unless you have support from Oracle or you really understand what you are doing in production, you should not touch hidden parameters. And this one, create table, if I just try it, so this will work because that parameter is true. But that's not the default case. Let's disable the parameter. Let's disable the parameter like this. Auto system set Exadata false. I'm going to restart the system because it's not a dynamic parameter. So that's why I had to use a scope SP5. This is the way to change the hidden parameter, double quotes, and the false is the value. Yeah, so let's start the system. So after that, just check the value of that parameter. Again, you can run the same query to check the value of the hidden parameter. So now if we check the value, it should be false. Yeah. Yeah, now Exadata page on, now it is false. You can see I disable the parameter. Now it is false. So now if you try to create that table, you are back to the original situation where your database is at the original situation. So now if you try to create that, let's make it 1 because I created that table earlier. So now if you try, what will happen? It should give that error. Yeah, so this is what I want to reproduce the error. I regenerated the error. And so this is the default behavior. Feature mem-optimized raw storage disabled due to missing compatible runtime environment. So this comes before 19.12 if you don't patch it. And but the workaround is to enable that Exadata parameter. So then that will get, this error will disappear. But if you don't know this one, you may try in this way. For example, now you may think, okay, let's set this parameter. Auto system set mem-optimize. You can set a value, no? Because this is the parameter where it takes a value for mem-optimize, the size of the mem-optimize within large pool. It will be set using this parameter. Within large pool, it will allocate this much of memory for mem-optimization. mem optimizer means pass start ingest. So pass ingest. And but if you enable this one, let's try it. Scope SP file. So sometimes you may get into trouble like this. Now I just modified that one. So these are all possibilities I am covering. Most of the possibilities I am covering. If you try to do this practical, that you may come across. Now I just modified that parameter and put a value. And now I am trying to start it up. Let's let it shut down. If I try to start up now, so you may get into trouble like this. Feature mem-optima row store is disabled due to missing. So that's a problem. Even if you, without enabling that exadata parameter, if you try to only enable this parameter, and if you try to restart, because this is going to modify my current SP file, and it will not even start the database, because now you are in a bit of a trouble because you have modified the SP file. So therefore, you won't be able to start the instance. So either you have to get back to your old P file and create this P file, or you have to export to your current SP file to the P file and modify the parameter in P file and re-export. So it's fine. That's why I'm not telling you to try out these things in production, because this is in testing for you to learn. So let's use the shortest path, since we don't have that much of important parameters in the SP file. So we can right away create SP file from our existing P file. And otherwise, if you have some important parameters in SP file, first export the SP file to a P file and modify this parameter, this one again manually, then re-export it to SP file. That can be done. So in my case, let me show you, I think the document, what is being done. Yeah, so same error is coming. You can see I have covered that one. And so we can take a look at normally, if you just try this command now, what I can do, I can right away try out this, create, let's see what happens. Create SP file from P file. Is what I can do now. Yeah, so now it says error, no such file or directory SP file, because unable to obtain the file status. So that is that because I may not have a init file in my default location. Because whenever you try this command, this is what going to happen. Oracle will look for a file. Which file? It will look for the parameter file, P file with the database name. My database name is TNH 19DB. No? So there should be a file called init TNH 19DB in my which folder? In my DBS folder. So let's go there and see. U01 app Oracle product 19.3 DB home and DBS. So in this folder, I should have a file called init TNH1, not TNH1. My database name was TNH19DB. So I don't have a file. No? There's no such file called init TNH-DB. So that's what it looks for. Whenever I'm saying create SP file from P file, by default, without any path, I can give the path. But by default, it will look for the parameter file in this particular folder, DBS folder. So the easiest way is, what is the easiest way? Now, there is a initera file in this place. If you locate your initera file, you can go here. I think it's under, let's go back. Yeah, it's under admin folder. If you go under admin folder, this is my database name, TNH19DB. So in this folder under P file, I have this file. You can see if I vi this file. Yeah, so this is the parameter file, the original parameter file for TNS19DB. This is the database name. And now what I can do, I can move this parameter file. I can copy this one in it to my location, this one. And while copying, let's rename this one as init. What is the name? The default convention is TNHDB. So that is my database name. You can see here. The folder comes as TNH19DB. Init TNH19DB.ora. So this is the file that creates SP pipe from P pipe will look for init TNH19DB.ora. Okay, so let's hear that. So now I am having that file in my location. Even if I visit here, just run ls. Now I am having init this one, init tnh19db.ora file is there. Fine. So now let's go to SQL classes as sysdba. Now let's attempt this one, create sp file from p file. Okay, file created. So now things are back to normal because my init file didn't have that previous parameter, mem optimize parameter, which gave the error to us. Enabling this parameter only caused the problem to us. So now I can start the system, start up. The database will come up now. So then what I have to do, the very first thing is before enabling this parameter, don't just enable this parameter initially, this one mem optimize. Before enabling this parameter, the first step is enable exadata parameter. Exadata feature on parameter. You need to enable this one first. This one first. Folder system, exadata scope SP file true. Then you shut down again. That will enable that parameter because it's not a dynamic parameter. After that, we can try to create our table. This was the table which you got the error previously. Let the system restart. Okay. So now let's try that one. You can see the feature, create table, the table name and 2 columns, mem optimize for write. So this is the feature. We are enabling parse ingest by appending this particular syntax. So let's see. Yeah, let's say mem opt1 already there. Let's make it mem opt. I think I dropped that one. Mem opt was dropped. Let's check it. Okay, let's drop table mopt right. So it's created, no issues. Table got created. There is no error this time because I have enabled exadata feature. Now it got created with the for write this parse ingest feature. But still, we didn't enable that parameter. So if I just run show parameter mem, the mem optimize parameter still we didn't enable. mem optimize pool size is still 0. Still 0 we didn't enable. Now, without enabling that, we can try to proceed our practical. Let's try it. Now, scope mem optimize here in this practical, I have changed that one. I had 100 MB for that, but it's no problem. Adding it will not do any harm, but we can try to continue without giving the specific size in large pool for mem optimization. Because if you enable this parameter, what will happen? Oracle will try to allocate that one because there is a algorithm how it works. The mem optimize parameter initially it will take 2 GB and 250 is like there's algorithm. Let's not go to that much of details. And feature, okay, restore, that's fine. And this is now done. Explain. So now what we should do, we should try to create the table. We created the table, yeah, and this particle is going in that way. So you can try to insert a record like this. So this is another point to notice. When you're inserting a record also, you're not just inserting, you can see the hint. So now since we have enabled the feature, enable the feature at the time of table creation. At the time of table creation, we mention this particular table will be utilizing mem optimize feature, that is pass ingest feature. Now, when we inserting, I have to give a hint. This insert operation should utilize pass ingest feature for this particular table. Now, let's, I think again, this has to be mem opt. Again, this table was using opt1, so let's change it. Our table was opt. Yeah. So that hint, this hint, okay, not create table, you should copy, insert into mem opt. This one I need to insert. Now we have already created. So this particular hint, this is a hint, will tell Oracle particular server process to use pass ingest to insert data to this particular table. So let's try it. Let's see what happens. One row created, so it got created. So if you want to see what happened behind, we can see this one. Select star from $B mem optimize write area. There's a $V file where we can check actually what happened on the background. So this one will tell, you can see number of writes 1. And now you can see it has automatically allocated 215. Now this is the mem optimized size. Let's see, show parameter mem. So mem optimized size, even though there is no value visible here, internally it creates the value automatically. Because when the feature is on, it creates. So this is the default value it takes 200 because it depends on my memory target value as well. Pass start this STA target actually. STA target to memory target. Whatever automatic memory parameter value depends on that one as well. And it is allocating internal space, and it is telling usage said this much, and the feature is working now. So that is what. So that is what basically pass start ingest is with the 19C feature with mem optimize write with mem optimize write hint as well as mem optimize. At the time of table creation, we define mem optimize this one table creation. This is mem optimize for write. So if you want further details, the documentation, you can see mem optimize pool size. So this is the parameter we were checking here actually. Mem optimize pool size is 0, even though feature is working, the parameter is 0. But if you go to this explanations, documentation, you can check mem-optimized pool size sets the size of the mem-optimized pool, a memory area in the system global area SGA used by mem-optimized row is low. Actually, it is within the large pool. The explanation will tell by default the 0 is disabled, and you can set the value. And it says the explanation. You can see if you want, you can read and see. And the mem-optimized improves. Okay, that's the same explanation for IoT. That's all. That's we explained earlier. And here you can see how is calculate the buffer cache requirement for the table being considered mem-optimized for read. That is read include on additional 25 memory requirements likewise. That is for indexing and all. But for this parameter, the value specified for this parameter counts towards HCA target. That's what I mentioned. Automatic memory enabling HCA target or memory target. For example, if your HCA target is 10 GB and you set mem-optimized pool size to 2 GB, then it's 20%. That's true. But there are additional logic as well. I'm not sure that is mentioned here. There is additional logic which is mentioned in other documents. That is for your reference. You can take a look at these things, because if you want to use this feature, I am just introducing the feature here, because this is we are getting familiar with the architecture. We are not going to deep dive this particular feature only. So, but you got to know the feature now. So for further references, you can check it out. You can see the database does not automatically shrink the mem-optimized pool when the buffer cache so shared requires memories. That's why. Or increase when you run out of memory. It doesn't. It will utilize the value that you have given for this size. You can only increase the size of the mem-optimized pool by manually. That's true. So if you don't give a value, there's a default value as well, starting from 2 gig to 256. Likewise, there's a default value. Now you saw that we didn't mention the value, but it has taken a value. This is, how much is this? This is in bytes, no? Originally it's bytes, no? And it comes to around 2 gigabyte, right? This is K, this is M, yeah. That's set to 2 gigabyte. That's the initial value actually. This is explained here as well. If you go here, you can see in the technical documentation also it is there. In this technical architecture document, they also explain in this one. Large pool. So this is what? This is what it says. The pool. This is about deferred insert pool. Pass ingest feature enables high frequency single row data insert database table defined as mem-optimized for write. So that's what we have to define the table with this tag that we did. And what it says, space management is the FMC process. We learned that one, and the writer processors, slave processors in parallel it writes. Process after 1 MB worth of writes session object. Okay, that's okay. You can read that. But what I want to mention is this: the pool is initialized in the large pool at the first insert of row. That's what mem-optimized. So when you insert for the first time, the pool is initialized. 2 gig is allocated from the large pool. So that is what happens actually. It allocated 2 gig automatically, so that if there is not enough memory in the large pool, ORA, this error internally discovers automatically cleared. That's true, but it's not going to disable the parameter. Allocation is retrieved with half the requested size. So if not 256, not 256, if not 2 GB is possible, if not 2 GB is possible, what's going to happen? Half. And allocation retrieved half the request. That means try with 1 GB. If it's not possible, again it's still not, then again it will try with 512, again half, again 256. So it will keep on trying, because If there is no sufficient memory in the database to get, I mean, in the system, if there's no physical memory, or if the database is busy and there's no sufficient large pool defined likewise, and then it will try these values 256M. Then even if not, I mean, at least 256 is not possible. It can't allocate. It is not possible to get at least 256 of memory from the SGA. Then what's going to happen? It will retire this and it will disable, after which the feature gets disabled automatically until the instance is restarted. So that's how the feature works. So in our case, that's why it took 2 gigabyte. I think my system is enough memory is there, and it's not busy. It's a learning environment. So, but these things you can, if you want to really utilize this feature, it's a very good feature in IoT environments, and you can try it out in more details. It's for your study, you can do it. Fine. So I think that explains that feature. Okay, so and the hands-on also, I will upload this document for the session. Yeah, so what next we have in our explanation, we have learned this one, and yes, so pass ingest also explained. And memory structure deep dive, after this is still large pool, we need to learn these things, how the shared server environment retrieves data. Because it's not like dedicated environment, the shared server, there is an order of how it retrieves records. So let's study the steps, how this dispatcher and the request queue, response queue, those things are working. So that we will do in the next session. All right. So I will stop here for this session. If you like the video, you can put a subscribe, and I'll meet you soon in the next session. Have a great time. Bye bye.